Welcome to Maths with EJD. Still on coordinate geometry. Our focus is on applications of circles. Before now, in the previous two videos, we've talked about, we saw the standard equations of circles. Then in the next one, we looked at the tangents and chords of circles. Here we're looking at, being the last video on circles, we'll be looking at applications of circles. Why do we need to know about the equation of a circle and things like that? So first of all, we can talk about distance in circle problems. So the concept of distance plays a major role in circle geometry. Distances are often computed from points to centers, from centers to lines, and between two circle centers, right? In the last video, we talked about like the length of a chord to the center of a circle and things like that, okay? Or the length of the tangent itself from an external point. So now here we have some key results, knowing that the distance between the center of a circle HK and any point x1, y1 is simply d, which is the square root of x1 minus h all squared plus y1 minus k all squared. So with the distance now, we can say that a point lies inside the circle if d is less than r, that is the distance is less than r. So the point lies inside the circle. Okay, on this, if the point lies on the circle, if d is equal to r, so if this distance is equal to r, and then the point lies outside the circle, if d is greater than r. So we take an example of that. So the question is check whether the point 2, 3 lies inside, outside, or on the circle x minus 1 squared plus y minus 2 squared equals 9. So all you just need to do is to find the, so we know the radius. The center, of course, of the circle is 1, 2. We can read that off directly, 1, 2. The radius is 3 because 9 is r squared. So which means r is 3. So now the distance from this center, 1, 2 now, to the point 2, 3 can be found as square root of 2 minus 1 squared plus 3 minus 2 squared. That will be square root of 1 squared plus 1 squared. That's root 2. So root d is root 2, which is approximately 1.41, and r is 3. Now, because the distance now is less, the distance is less than the radius, then we can say that the point lies inside the circle. The point 2, 3 lies inside the circle. We can visualize that for sure. So x minus 1 squared, y minus 2 squared equals 9. Okay, x minus 1 squared plus y minus 2 squared equals 9. So that's a circle like that. Then we have seen that from this calculation that the distance is less than the radius. As a result of that, the point 2, 3 lies within the circle. So let's see, 2, 3. 2, 3. So you see it lies inside the circle. Okay. So then we talk about locus. So one application of circle is that we can find the distance between, from the center of a circle to any other point, right? So, and we can find out if a point lies within, on, and outside. Like in previous videos, we have seen that if a point will lie on a circle, it means that if the point x1, y1 lies on a circle, it means that x1 squared plus y1 squared must be equal to the radius squared, right? Then we have locus in circle problems. So I think one of the definitions of a circle I really like is the fact that a circle is the locus of points always equidistant from a fixed point, right? So a locus is the set of points satisfying given conditions. So like a circle itself is a locus of points satisfying the fact that the point is always is of equal distance from a fixed point. So many circle problems can be rephrased as finding a locus. So common applications, locus of points equidistant from a fixed point or center. That simply talks about a circle, like I've been saying. Then circle as locus of points satisfying a condition, like square root of x minus x1 squared plus y minus y1 squared plus square root of x minus x2 squared plus y minus y2 squared. And that is always a constant like that. Then let's take an example. Find the locus of points equidistant from 0, 0 and 4, 0. Okay? Locus of points equidistant from 0, 0 and 4, 0. In that case, of course, the locus of points always equidistant from two fixed points will always be the perpendicular bisector of that point, right? So imagine that we have 0, 0 and then 4, 0. So 0, comma 0. That's the origin, and then 4, comma 0. So you can see the point here. So of course, obviously, uh, if we have this line joining 0 to 4, so the local point always equidistant from these 2 points will be the center, which is simply x equals 2, as you can see. So that's what's happening here. So solution, let x and y be any given point. So the condition is square root of x squared plus y squared equals square root of, so like so square root of x squared plus any particular x minus 0 squared plus y minus 0 squared equals x minus 4 squared plus y minus 0 squared. So if you square both sides, you have x squared plus y squared equals x minus 4 squared plus y squared. If you simplify, you have x squared plus y squared equals x squared minus 8x plus 16. X cancels out, so you have 8x equals 16, and x is equal to 2. So hence, locus is the vertical line x equals 2, which is the perpendicular bisector of the line joining 0, 0, and 4, 0, like this. Okay? X equals 2. So, that is the locus of points there. Then example 3. Find the locus of points whose distance from 0, 0 is 5. In this case now, we don't have 2 points, we just have 0. Okay? And then we just have the origin 0 and 5. So if it's the locus of points always equidistant from a fixed point, this fixed point times 0, 0, which is 5. So the locus of point that satisfies that would definitely be a circle of radius 5, right? So in this case now, the condition is square root of x squared plus y squared equals 5, right? So in that case, this squaring, we have x squared plus y squared equals 25. So this is a circle with center 0, comma 0 and radius 5. So we have x squared plus y squared equals 25. Okay? So you can see this is the locus of points, always equidistant from the origin 0, 0. Like that. So from here to here, this is 5, 5, 5. Like that. Then we can talk about symmetry. Symmetry in circle problems. Circles are symmetric about their center and the coordinate axis, for sure. So equation of a circle is unchanged when replacing x by minus x or y by minus y, because it's squared in the first place, right? A square centered at the origin is symmetric about both axes. I mean, a circle centered at the origin is symmetric about both axes and the origin. So if x comma y is a point on the circle, then minus x comma y, x comma minus y, and minus x minus y are also on the circle, right? So look at this. Show that the circles x squared plus y squared is 25 is symmetric about both axes, of course. So how do you do that? The circle is x squared plus y squared equals 25. So if you replace x with minus x, that's minus x all squared, which is still x squared plus y squared equals 25. Replace y with minus y. You have x squared plus minus y squared equals 25. That's still x squared plus y squared equals 25. So anyhow you change it, it's symmetric. So equation unchanged in both cases. Symmetric about both axes. Let's say x squared plus y squared equals 25. We already have that. So Mm, of course, we know that the point 3, comma 4 will lie on the circle, right? So 3, comma 4, that's it lies on the circle. So what we are saying is that whatever sign, since 3 and 4 lies on the circle, if you like, change the sign to minus 3, comma 4. You see, it also lies on the circle. So that talks about the symmetricity. Bring it now, and then you have 3, comma minus 4. 3, comma minus 4 still lies on the circle. So come here and do minus 3 minus 4. So minus 3 minus 4 also lies on the circle, so you can see. So once the point x comma minus y lies on the circle, then no matter how you change the sign of x and y, they will always lie on that circle. Very interesting about the circle, talking about its symmetricity. Then equation 5 now, example 5. Verify that 3, comma 4. Okay, in fact, that's just what I did. That's just what I did now. Okay, verify that 3, comma 4 lies on x squared y squared equals 25. Then minus 3, comma 4, 3, comma minus 4, and 3 minus 3, comma minus 4 also lie on it. So you see, if you put 3, 4, 3 squared plus 4 squared is 9 plus 16, 25. Minus 3, comma 4. Minus 3 squared is still 9. Plus 4 squared, 16. That's 25. 3, comma minus 4. 3 squared plus minus 4 squared, that's 9 plus 16, 25. Minus 3 minus 4. Minus 3 squared plus minus 4 squared, that's 9 plus 16, 25. So that symmetricity holds. And that's exactly what I showed here previously on this graph. Okay? Once you find a point on a circle, change the signs anyhow you like. But as far as you fix those values, it will always be found on the circle. So in summary, circles have application, they have distance applications, right? Like when you talk about determining whether points lie inside or on or outside a circle. So if points lie inside a circle, it means that the distance between that point and the center of the circle will be less than the radius. So if the point lies on the circle, the distance will be equal to the radius. If they lie outside, the distance will be greater than the radius. Okay? So because we also have Locus applications, so we can translate geometric conditions into circle equations, right? Then you have symmetry applications. Use invariance of circle equations under sign changes in x and y, like we just showed with 3, comma 4, 3 minus 3, comma 4, 3, comma minus 4, minus 3, minus 4, minus 3, comma minus 4. So we see that all these worked examples illustrate how these principles apply in problem solving. So you have some practice questions. You want to try your hands on this? Okay. So talking about practice question now, find whether the point 5, comma 7 lies inside, outside, or on the circle x minus 3 squared plus y minus 4 squared equals 2.2, comma 0. Equals 20. So of course, the first thing you want to do here, the radius is square root of 20. That's 4 point something. And then the center is 3, comma 4. So the distance between these two is just the square root of 5 minus 3, 2, that's 4. 7 minus 4, that's 3. So, so 5 minus 3 is 2 squared, that's 4. Then 7 minus 4 is 3 squared, that's 9. So 4 plus 9 is 13. So root 13 is 3 point something, while the square root of the radius of the circle is 20, that's 4 point something. So that means that 4.5, comma 7 lies within that circle. Let's verify with this, let's verify on the graph. Okay, again, x minus 3, y minus 4, 20. Okay. Okay. X minus 3 squared plus y minus 4 squared equals 20, as you can see. And then we have points 5, comma 7. From my calculations, if that was right, 5, comma 7 lies within the circle, and that's true. It lies within the circle because the distance from this point to the center of the circle is less than the radius. So the distance is square root of 13, while the radius is square root of 20. So, and since the distance is less than the radius, then the point has got to lie within the circle. Then we have the equation of a circle is x squared plus y squared equals 100. Check if the point 68 and 10, 0 lie inside and all that. Of course, the radius here, the radius here is 10, okay? And the distance from here to the center is also 10. So this 6, 8 will definitely lie on the circle. Then 10, 0 will be like, yeah, I think they both lie on the circle. 6, 8, 10, 0 will lie on that circle, I believe. Because 10, 0 will also give the same square root of 10. So we have x squared plus, x squared plus y squared tells us that the circle has center at the origin. 100, that's the radius. Okay. Then we now have 68.68, 6, 8. So you see it lies on the circle. Then 10, 0, 10, 0 will also lie on the circle easily. Okay. Then anyhow you vary these ones now. If you now do, let's play with all the 6, 8. Okay. So see, minus 6, 8 will lie there. You can see this. Then 6 minus 8, 6 minus 8 is there. Minus 6 minus 8 is there. Then 10, 0, that's easy. So the other thing is minus 10, 0. Okay, minus. So they all lie. So this here, minus 10, 0, they all lie on the circle. So try your hands on the rest and see how it goes. Don't forget to comment, like, and share this video so that more people can have access to the great content I'm going on it. Like, come your way again. Keep doing math right. Subscribe, hit the notification bell so you can always get alerted each time a new video is released. Bye.